or any question, you can let me know before we start discussing about this Kirchoff law. Okay, if everyone is good, all right. So good morning, everyone. So I hope everyone is in good health. Okay. So from last week, we already discussed about the voltage divider and current divider. Okay. So I hope you know how to apply that. Okay. And then we will look into certain problems later. Okay. I will give you the exercise. Right. But today, first we're going to discuss about the Kirchoff law. Okay. So how this Kirchoff law works? Okay. So the law states that the current flowing into a junction, okay, in a circuit, okay, or node must equal the current flowing out of the junction. Then if you see a junction, okay, this is a junction. Okay, at the middle here, there is a junction. Okay, from I1, okay, I1 meet a junction. Okay, and then at the junction, it is separated into two, I2 and I3. Meaning that, okay, I1, okay, should be equals, okay, should be equals to the I2 and I3. Meaning that if I1 is 20, okay, 20 amp for example, okay, and I2 is 15 amp, and I3 should be 5 amp. Okay, so that's it. Okay, and you see, you note that the direction of the current itself. Okay, so if it is flowing, okay, flowing in, it must be equal to the flowing out. Or if all of those are flowing in, okay, if the direction are all flowing in, then the summation of that should be 0. Okay, the summation of the current should be 0. Okay, meaning that in the direction I1 to that junction, I2 to that junction, I3 to that junction, so the total I should be 0. Okay, and then there is another second law. All right. For any closed loop path around a circuit, the sum of the voltage gains and voltage drops equals 0. Okay, so meaning that if it is involving a voltage, all right, the sum of voltage gain and voltage drop equals to 0. Okay, so what we have here, let's say we have the V source. Okay, V source, let's say 5. Okay, here voltage over there should be, after it meets here, it should drop. Okay, it should drop. Let's say at the point there, I should see, let's say if this is 2 volt, okay, if you measure that it's 2 volt, so you should measure here is 3 volt. Okay, so this one, okay, should measure 3 volt. Okay, and then at here back it will be 0. Okay, so after summation all of that, it should be 0. Meaning that 5 volt, okay, it is minus 2 minus 2 volt, okay, and then minus 3 volt. So you should get the summation of that as 0. Okay, so that's the Kirchoff law. Okay, so we have a couple of rules to follow. All right. The signs of the potential drops are going from higher potential to lower is negative. Okay, going from lower potential to higher potential is positive. Okay. The polarity of the potential difference across each resistor is marked higher potential and lower potential, as you can see here. Okay. Okay, if you see that current flowing, right? Current flowing to that side. Okay, so the voltage is minus IR. Okay, minus IR. Okay, because from positive to the negative, right? R is from positive to negative. Okay, if it depends on the potential, how the potential direction is going. Okay, but if the potential going to that direction, okay, like the bottom here, okay, if the potential going to opposite direction, then you should have a positive. Okay, you should have a positive IR. Okay, so it depends on the polarity of the voltage sources. Okay, for a long bar, okay, as you know that for a long bar, then it is positive. For the short bar, it is negative. Okay, so it is negative, it is positive. Okay, so what you need to do is to assign a current of arbitrary direction to each of the resistors in the network. So it doesn't um, it doesn't um, it depends on you actually. It depends on you to which way, which side that you want to draw the current flowing. Okay, but the thing is, if you draw that to a certain direction, let's say from left to right, then you need to make sure that the current that you obtain is correct. Okay. For example, over here, let's say you have I1, okay, I1 over here, and then that resistance is from positive to the negative. Okay. And then for I2, if it is going to the other side of I1, it is opposite to I1, okay, mean that it meets to a junction, okay, then the resistor polarity is still from positive to negative. So resistor direction will be following the current direction, okay, and then I3 is going out of the junction, mean that I3 is equals to I1 plus I2. Okay, over here I3 is equals to I1 plus I2, meaning that the resistance at the I3 will be from positive from the top one and then to the negative at the bottom. Okay, so that's how you do applying the Kirchoff law. Okay, um, if you have multiple closed loop, all right, okay, how you want to define, okay, whether it is flowing the clockwise direction or anti-clockwise direction. Okay, so it depends, right? So it depends on this. If there are n nodes and m unknown currents, okay, then the number of equations to write from n minus 1 current equation. So you have that number of current equation. Let's say you have how many nodes? Let's say you have 5 nodes. Okay, if you have 5 nodes, so that means you should have 4 current equations, and then you will have m number of unknown current. Okay, so let's say you have 5 and then you have seven unknown currents. Okay, so from there you will have 3 voltage equation. Okay, so that's the example. Okay, all right, so let's look over here. Okay, so let's look over here. Okay, what is the current in each resistor? Okay, so first of all, you see that, okay, You see that the voltage in which direction? Okay. Okay. So here is negative, here is positive. Okay. So it is positive, it is negative. So how do you want to solve this? You can assume it is flowing to that direction. Okay. Or you can assume it could be on the other direction. Okay, it depends on how you apply that. Okay, and then you have another voltage source over here, plus and also negative. Okay. Okay, let's say I assume that it's flowing to this direction. Okay, mean that both of that is flowing to that direction. Okay, so what would be the current? So we have here I1, I2, and I3. Okay, so we have 3I. Okay, so what is our I? Okay, first we know that our current equation would be, okay, so according to the law here, okay, okay, how many nodes that we have? N nodes. And how many unknown currents? We have 3 unknown currents. Okay. So we have how many nodes? We have one node. Okay. And then we have another node over here. Okay, 2 nodes. And then we have N equals to 3. And M sorry, M equals to 3 and N equals to 2. All right. So from here, how do you create the equation? So what the rule says? Okay. The rule says that, so we have how many current equation? We have one current equation. And we have two voltage equation. Okay. All right. So what we have here is I1 equals to I2. Sorry, I1 plus I2 equals to I3. Sorry, I1, this should be I3. Okay, so meaning that I1 plus I3 equals to I2. Okay. Okay. Right. So that's the equation that should be. Right. Then, okay. What is the equation All right, for this one. All right, for this voltage. Okay, what do you have over there? So what you have is that I2 and R2 plus I1 and R1. Should it be negative, right? So it should be negative V. It's negative 32. Okay. So what is your I1? And you still haven't know it, right? And you still haven't know. You only know what is your R only, right? Right now you only have your R only. And then you make another equation, all right? Say minus 20 equals to I3 R3 plus I2 R2. Okay. So how do you want to solve this? Okay. You can either choose to do the replacement method or the elimination method. Okay. So you have over here I2 and R2. So you can do the elimination. You can try to calculate it. If you eliminate, all right, meaning that if you can do okay, let's see what you have over there. I2 and R2 you can minus. Okay, I2, I1 and R1 minus I3, I3. Okay, so you obtain another equation there. Okay. All right. So what is that? So minus 32, minus 20. So you obtain minus 12. Okay, minus 12 equals. So anyone want to help me today? I1 and R1 minus I3 R3. Okay. So how do you deal with that? So once you obtain this, all right, so you also obtain the value of R1 and R3. All right, so R1 is 2, 2 I1, all right, and I3, it is what is your I3? 4 ohm. 2 I1 minus 4. I3. Okay. Then you need to find out, okay, how to solve this. Right, so you have I1, okay, and I3, okay. But now you also have, okay, I1 plus I2, I1 plus I3 equals to I2. So how do you solve this? You must first, you must first, okay, right now you still have three variables over here that is unknown, okay. So basically you need to know, okay, you need to know at least, all right, one equation to be solved. So you still have here, it is, what we have over here is, uh, either you can take this, all right, I1, okay, and then plug in back, okay, into this, right, and then you obtain your I2, right, okay, you obtain your I3 in terms of I2, or after that, you can plug in back into those equations, okay. You could try to do that. Okay, I cannot give you the solutions over here because it's taking too much spaces. Let's try to calculate first, all right? I'll give you 10 minutes, okay? And then we will see what is your answer, okay? So you can take your 10 minutes to do that, and then I will continue, okay? We see if those haven't obtained it, so we see how to solve that, okay? So we stop here for a while, okay? I meet you at 9 a.m., okay? Okay, have you guys got it? Anyone got it? Nobody knows how to solve it?
No, yeah, doctor. I'm stuck.
Okay, let me look again, all right, for this example. Okay, all right, so this should be, okay, there's a little bit mistake over here. Right, this should be all right. This I1 R1, okay, okay, I1 R1 plus I3 plus I2 R2. Okay, that's correct. Okay, uh, but this one is 32, all right? It's 32. Okay, because we equals to that, unless we put it as minus 32 plus I1 plus R1 plus I2 R2 equals to 0. Okay, then it should be correct. Okay, so that's the voltage equation, right? And then for the second one, should be over here, it is minus 20. Okay, it should be plus 20. Okay, velocity equals to, okay, I3, okay, plus I3, okay, and then minus sorry, plus I2 R2. Okay, so that's the two equations over there. Okay, and then you have I1 plus I3 equals to I2. Okay, you need to plug in. Okay, to make it easier, try first to plug in I1 plus I3 equals to I2 into this equation. Okay, meaning that what you have, uh, okay, you have 32 equals I1 R1 plus I1 R2 plus I3 R2. Okay, so you can plug in the values over there. So you have 32 equals to I1. What is your R1 and R2? 2 plus 8. Okay, so it's 10 I1. So 32 equals to 10 I1. 10 I1 plus what is your R2? R2 is 8. 8 R3. Sorry, 8 I3. Okay, so that's your first equation. And then for the second equation, it is 20, all right, R3 plus R3, I3 plus I1 R2 plus I3 R2. So I3 plus R2, what is it? It is 12. Okay. So your second equation, you obtain that as 20 equals to, so it is 12 I3 plus what is your I1 R2, I1 is 8 I1. Okay, so it's 8 I1. Okay, so that's the two equations that you need to solve. Okay, so you can use the replacement technique over here. Okay, for this one and then this equation to solve. Okay. All right. So what will be? So it is your I1. It is so I erase this one. I erase this one. Okay. So it should be your I1 is equals to, if I take from here, okay, so 20 minus 12 I3 so what you have there, it's it is actually, you can, to make it simpler, I think you can just reduce this one. Okay, so because you have I3 over there, so let's erase that again. We have 10 I1, 10 I1 plus 8 I3 equals to 32. Okay, and then you have another one is 8 I1 plus 12 I3 equals to 20. Okay, you can reduce both of this equation, okay, to make a new equation actually. As you can see, if you divide by, I think it's much easier if you just divide this one, right? You divide this one by 4, okay? Sorry, you divide this one by 2, and then you multiply that with the with 3. Okay, then you get 12 over there, and then you can eliminate that. Okay, so to do that, so if you divide by 2, so you have 5, and 5 times 3, it will be 30. Okay, and then here you have 12. You have 12 I3, and then you have over there, you divide by 2, you obtain that as 16. Okay, 16 times 3 is 48. Okay. So now you can eliminate that. Okay. So it's minus, minus, minus. So what we have there is 28, okay, equals to 22. All right, 22 I want. All right, so you should able to obtain your I1 now. Okay, so I1 is 28 divided with 22. Okay, so that's your I1. And then after that, so I1 is 28 over 22 volt. Okay, you can calculate it. All right, and then you replace 28 over 22, okay, into I3 equation. Okay, on top of here, you can replace it. Okay, let's say you put over there, okay, is 8 times 28 over 22 plus 12 I3 equals to 20, and then you can solve for I3. Okay, so that's the should be the answer. Okay, everyone managed to get it. So what is the answer in decimal number? Anyone can give me the answer? Because I don't have my calculator with me right now. Anyone can give me the answer? What is 28 divided by with 22?
1.27.
Okay, 1.7. And then what is your I3? 1.27. That's for I2. Sorry, this is for I1.
Doctor, for I1, 1.27.
1.27. Okay, 1.27.
For I3, I think the answer is 2.41.
2.41. Okay. Thank you, Vienna. All right. So, anyone didn't get this answer? 3.2, right? I3 is 3.2. Vienna?
I got 2.41.
Okay, 2.41. Okay, that should be the answer. So anyone that doesn't get that answer, so you can let me know if you have any problem to obtain the value of I1 and I3. If everyone is okay, then I move to the next problem. Okay. All right. So let's say we have a Wheatstone bridge. Okay. So this is a Wheatstone bridge. Okay. So you have multiple nodes, all right? In that you have multiple junction over here. Okay, and this is how you solve it. Okay, so if you have over here, you have a junction A, right? The junction A, you have current, Okay, from here is I. Okay. So I, we have I over there. And then when it meets A, okay, and then it is separated into I1 and I2. Okay, I1 and I2. So meaning that I equals to I1 plus I2, or I minus I1 minus I2 equals to 0. And at junction B, you have I1, okay, it is, okay, I1, okay, I1 over there. And then you have I3, and then you have I5 coming to that direction. I5. Meaning that I1 plus I5 equals to I3. Okay, or I1 plus I5 minus I3 equals to 0. Okay, and then we have at junction D. At the junction D, what you have is that, okay, this one, you have I3, and this one I4, and then outside here, you have I. Okay, you have I. Okay, all right. So meaning that I4 plus I3 equals to I. Okay, or so this is I3. Okay, I3 plus I4 equals to I, or I3 plus I4 minus I equals to 0. Okay, so this is what you have. This is the current equation that you should have in the Wheatstone bridge. Okay, for the loop, okay, we look into the voltage equation. So we have 3 loops as well. Okay, this is the first loop. Okay, as you can see, okay, over here, so inside here, it is the first loop. Okay, so that's the first loop. Okay, this is the second loop. Okay, and then this is the third loop. All right. Okay, for the first loop, so because it is in terms of voltage, all right, so you should read it in terms of voltage. So we have V over here, and then you have minus, okay, I1, okay, you have minus I1 because your voltage is flowing that way, all right, so it is minus I1, so it is opposite of the direction of the voltage, okay, minus I1, R1, and minus I3, R3, okay, plus voltage, okay, that's equals to 0. Okay, so that's for the loop number 1. Okay, for the loop number 2, okay, okay, over here we can, okay, because okay, this one, okay, is considering the bigger loop, all right, as you can see, the loop number 2 here is considering the bigger loop, so meaning that it's not considering this one. R3, R4, and okay, so meaning that it takes this loop, okay, from there to there. All right, so mean that your second loop is V minus I1 R2 minus I1 R2, V minus I2 R2 minus I4 R4 equals to 0. And then the last one, it takes the loop at the top here, small, for the small loop over here. So it is, okay, what you have is So because the voltage is flowing to that that side, okay, so it's minus I2 R2, okay, minus I2 R2, and then minus I5 R5, and then because it's flowing back to the opposite direction, okay, and then it is plus I1 R1, okay. So that's for the loop number 3, okay. Okay, so that's how you solve it. Either, okay, you can also take another loop over here, small loop at the bottom there. Okay, it is possible as well if you want to take it. Okay, mean that at the bottom there, if you want to take the loop, it should be minus I4 R4, okay, and then plus, okay, plus I3 R3 plus I5 R5, okay, equals to 0. Okay, that's the way you should read it. Okay. Okay. All right. Let's say we are given. Okay. Let's say we are given these equation, these values. All right. For voltage, for the supply voltage, R1 to R5. Okay. So we have R1 to R5. Okay. And then you can try to solve that. Okay. So you have those equation there. Okay. From the what you created just now. Okay. And then we have the voltage, okay, and also the resistance value, okay. Okay, you can use this, right, and then you reduce the equation, okay. You can reduce the equation to 3, okay. Because why? Right over here, okay, let's say you have, okay, this equation, okay, and then, okay, this equation is remain 100 I1 plus 80 I3 minus 30 equals to 35. Okay, and then for the second one, okay, we can reduce this, okay, by plug in, okay, by plug in the equation of this, right? So I2 you can replace with uh, I and I1, okay, right? So this one you can replace that. So 90, okay, 90 I minus 90 I1, okay, plus 110 I4 you can also replace with this one, okay, 100, okay, 110I, okay, minus 110I3, okay, equals to 35, and it is reduced to this one. Okay, you obtain 200I minus 90I1 minus 110I3. That equals to 35. Okay, similarly for this one, okay, so this one I1 you can retain, okay, you can replace I2, okay, so you can obtain the equation in terms of I1 and I, and also you can reduce the I5 into I1 and I3, okay, you obtain this equation. Okay, now you have 3 unknown variables, okay, for that you have 1 2 3 4 5. Okay, you have 5 unknown variables. Now it is reduced to 3 unknown variables, which are I, okay, I1 and I3. Okay. Now, all right. Once you have this, all right, what you can do is, okay, you can use a matrix method. Okay, you can use a matrix method to solve these 3 equations. Okay. So the way you did this is, right, because you have set of I1, I1 and I3 equals to something, right? So you can use that to solve that using the matrix equation. Okay, so like this one, if those, okay, if those you make it equals to I1, so it would be like this one, right? Because, okay, over here, you need to see how you want to get the I, right? So this is how you solve it. Okay, so you need to take the 35, okay, and over here is still 35 minus 90 minus 110, okay, and then you need to divide this, right? You need to divide this with that 200, okay. So this is the below one, okay, that's the 200, okay, and then for this one, okay, you still need to take out a minus 90, okay, for I, okay. So what is the way you did it is, okay, you put it as minus 2, okay, over there, okay, it will be 0, okay, 192 and minus 2, and then over here, all right, at the bottom here, you just divide whatever values, all right, whatever values of I has at that time, okay. This is 0, 200 and minus 90, okay, and then over here just replace with the same value as the one that you obtained at the numerator, okay. And then to solve this, right, so how to solve this, all right, use the mathematics method to solve this matrix equation. So it is, okay, from here you need to multiply, right, multiply and plus, okay, multiply and plus, and then you obtain all of the summation, so you obtain the part of the numerator, and then you obtain the part of the denominator, and then finally you will obtain what is your I, okay. So once you obtain your I, and then you can plug in, okay, you can plug in into this equation, and then now you have the simultaneous equation where you need to solve for I3 and I1, okay. After that, you can use I1 and I3 to solve for I4 and I5 and I2, okay. So that's the way how you should do it, okay. Any question? All right. If no question, then let me continue with the last part of this basic circuit theory. Okay. So I hope you already know how to solve a circuit using the Kirchoff using the Kirchoff technique. All right. And also this is the one the Thevenin equivalent circuit that you need to know as well for this basic circuit theory, because it will be used in the later part of the course. Okay. So what is the Thevenin equivalent circuit? Okay. So the Thevenin theorem states that any linear two-terminal network can be replaced, okay, by an equivalent circuit consisting of a single voltage source, okay, and a series resistance RTH. Okay, so this is the Thevenin. Okay, so meaning that whatever you did, if it is a complex network over here, you should replace that with VTH and RTH. Okay, so over here, you want to reduce it. Okay, you want to reduce it, so you need to make only one resistor, okay, out of this. All right. So this should be easy, right? So because you can find what is the equivalent value over here, and then you sum up this one and this one and also this one. So you obtain what is your R. Okay. Alright, so the way you can solve using the Thevenin Theorem, okay, let's say you have a circuit here, alright, elements to be studied, remove, okay, let's say over here, you remove RL, so this circuit will be open, okay, and then, so the open end terminal is labeled as VTH, and we need to determine what is our VTH, okay, we need to determine what is our VTH. Short circuit all voltage sources, okay, need to short circuit all voltage sources and open circuit all current sources. Okay, so if there is a voltage sources, we need to do a short circuit. Okay, meaning that we need to short that. Okay, so that's how we short that. Okay, if it is current, then leave it open. Okay, and then we calculate what is the current, what is the equivalent resistance RTH, and then connect the VTH, RTH, and the load resistor in series to form the Thevenin equivalent circuit. Okay, so this is how the way how we do it. Okay, so we already remove RL over here, right? Okay, and then what is our VTH? Okay, so our VTH is over here, should be somewhere over here. Okay, so we need to replace that. Okay, we need to replace that. So the VTH, okay, if we look to that side, okay, so if we look to this side, it is actually 50, okay, divide with, okay, 50, right, this is 50 volt, okay, plus 20 and plus 20, which is the resistance, okay, which is the resistance, okay. So you obtain your VTH, right? So this should be your VTH over there. Okay, and then what is your RTH? Okay, your RTH would be, okay, because when you short this, okay, so you obtain over here, it is 40. And then this should be 50. Okay, because it is in series, in parallel. Okay, so it is in parallel. Okay, this one and that one in parallel. So you solve using this equation. So you obtain your RTH over there. Okay. Okay, now you connect back, okay, your RL over there, and then you already obtain your VTH and RTH. Okay, and then now you can know, or what is your, then you can know what is your RL. Okay, so your RL, okay, so your IL first will be Okay, if you're measuring the current over there, so it should be VTH, okay, over RTH plus RL, right? Okay, because in series circuit, okay, the way it is, this is the current divider, okay. So you will know what is your IL, okay, and your VL is equals to RL, okay, over RTH plus RL, okay. So times the VTH, so you know what is the uh, voltage over that, okay. So which is 54.35 and 0.45, and then you will know what is your RL, okay. You multiply both of these, then you will know what is your RL. Okay, any questions so far? So I'm going to the last part, right? I'm going to the last part for today's class, right? So this is the last part for the basic circuit theory as well. So just now we see that how to solve, okay? How to solve uh, the circuit, right? The circuit using the Kirchoff voltage theory. Okay. Now, how we can use the Thevenin circuit theory to solve for the Wheatstone bridge circuit. Okay. Let's say we want to know what is our R5. Okay, we assume that R5 is our RL. And then the rest we assume that as R Thevenin and V Thevenin. Okay. All right. So this would be the way you did it is you need just follow the steps like this one. Okay. First, you need to make it as open circuit. Okay. So when you make it as open circuit, then this R value, okay, you will know what is your R equivalent. Okay. Let's say you're given R1 and R2 and R3 and R4. So R1 and R3 would be series, and R2 and R4 would be series as well. Okay, and then you make it parallel between these two, between R1 and R3 and R2 and R4. So you make it as parallel of that. Okay, and that after that you will need to find out, okay, what is your VTH. Okay, so once you obtain your VTH, right? So like this one. Okay, so you have the circuit there, right? So you know what is your VTH. Okay, and then you will able to calculate your VTH like this one as well. Okay, use the value of resistance of both of that, and then with the value of V that is given from previous slides. Okay, okay, part of that so would be VTH, and then now you already have what is your VTH and RTH. Okay, after that you can assume that it is a short circuit, right? Because it is a voltage source, right? Okay. Later you will able to calculate, okay, what is your I5, and also what is your V5. Okay, so that's how you solve it. Okay, any question? I will give you exercise, all right? So you will get to understand more on how to solve this, right? Okay, but it might be a bit it's between this week, all right? It is between this week, so might be I've given it after class tomorrow. Okay, most probably. Any question, by the way?
Doktor,
Yeah.
boleh tak kalau doktor macam yang RTH tadi, yang slide tadi, slide sebelum ni, yang
ni.
dari satu.
Okay.
Yang ni saya macam RTH ni macam mana datang 40-50 ni saya tak faham.
For this one, ini 50. Okay.
40-50.
Okay, you assume, okay, this circuit dah short kan, right? You assume this circuit is short. So 20 akan jadi macam ni lah. 20. Alright, and then yang ni akan jadi 100 dengan yang ni 100. Okay, yang ni 20. Yang ni 20. Yang ni 100, right? Yang ni 100. Nampak tak sekarang?
Okay, nampak.
Okay, ini 40. Ini 40 kan? Okay, sebab yang ni dia parallel. 100 and 100. So, 1 over 100, 1 over 100, okay? 2 over 100 kan? And then 100 over 2 equals to 50. Okay, so yang ni jadi 50 lah. Right?
Saya lupa yang 1 over tu. Okay.
So you get 40 and 50. So still kat sini is still parallel. So you need to solve like this one lah. Okay. 1 over 40 plus 1 over 50. Okay. Equals to 1 over RTH. Okay. Ataupun you can use this technique. Okay. 40 times 50 over 40 plus 50. So you get the answer. Alright.
Okay, Doctor.
Okay, any other question? Okay, if no question, then let's stop here. Alright, so before that, for me to take your attendance, please turn on your camera. Everyone. Where are the others? Okay, I'm gonna wait for another 10 seconds. So 1, 2, 3. So we only have 9 here.
Doktor tak boleh buka kamera saya.
Tak boleh buka.
Kamera saya.
So how about the others? Alright, I'm gonna count from 10. Okay, get ready. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, cheers everyone. Okay, thank you. Alright, so see you tomorrow. Okay, enjoy the rest of your day. Okay, bye-bye. Assalamualaikum.
Okay, thank you doktor.
Thank you, Doktor.
Thank you, Doktor.
Thank you, Doktor.